Desk of Ladyada.
Hey everybody, and welcome to Late Night Desk of Ladyada. All night, can't stop, won't stop, doing engineering, finding alternative for components are out of stock. Never boring here at the House of Fruit.
Yeah, we were filming some cool stuff today at the Adafruit factory. Maskless because we're vaccinated, so no masks for us on site. And everyone around us was vaccinated too.
Yeah.
We're going to have some folks that we invited from the Mech Keys Discord. Hello.
Hi.
I wanted them to see the RP2040
Oh,
MacroPad.
okay,
So
cool.
I've been giving them some updates that we're making some Keebs, and I think this will be really handy because they also have some part shortages. But we'll get to the hardware in a sec.
Okay.
And then we'll also, I'll just talk about the logistics for the week.
Yeah.
We have our shows on Tuesday, JP's Product Picks. And then on Wednesday, we have Show and Tell. And then Wednesday night, AdaBox. And then we'll release the rest of the videos we normally do. And then Thursday, JP's Workshop. Fridays, Deep Dive with Scott. So, without further ado, Ladyada, what is on your desk this week?
Okay, as we mentioned, we've got keyboards. The keyboards are on the loose. You want to show them what the keyboards look like?
Yeah, we have a logo.
You want to show them that first?
Yeah, sure.
Do you want me to go?
No, I have a logo. So one thing, sometimes we have a bunch of different logos, and we don't choose one or different ones because they're too extreme or anything. I think someone on Twitter is like, "Oh, the fuddy-duddies in management." It's like we are the least fuddy-duddy.
It's not. It's just we just go with something good.
And so the ones that I'll zoom in. So
I kind of like this one.
So this is keyboards, and there's a little boar, and there's a keycap thing, and there's another one. But we're going to start with this, and this is just the beginning of it, and then we're going to do a full character around this because we like the idea that we could put this on a PCB, and it'll look good. It's one color. It looks fine reversed as well. And so
that's
we're going to
something
start
that
with
you
this.
can print on the silk screen of a PCB. That's for sure. So that's the thing. It's like it's not like we can do anything anymore.
So we're going to start with that.
Yeah.
And I think we're going to do something with these characters, but these won't be the logos. But just that gives you an idea.
I kind of like the character, but yeah, it probably won't be a logo.
The character will be standalone when it's more than just like a PCB or something.
Okay.
So let's show one of our first keyboards.
Let's show the keyboards. Oink, oink. So this is the board. So I put together two, and this is... so it's dark because it was like you had bright stuff. So let's lighten it up a little bit. So this is our 3x4 keypad. There's a little NeoPixel under each key. These are Chaos plug-in switches quite easily. And then for the microcontroller, this is a rotary encoder. This is the back of the rotary encoder. And then this is the USB-C right in the center, and it goes into an RP2040. With 8 megabytes of flash, and the flash memory stores assets such as macro command files, firmware. It can also have HTML files or like other like executables, whatever. What's kind of neat is I was thinking my keyboard actually, when you put it into like boot V drive mode, I have a Kinesis Freestyle. If you press two keys, it shows up as a disk drive with like the configuration software on it. I was like, okay, so that's kind of similar to CircuitPython. So it has 8 megabytes of flash. It's plenty of flash memory. It's quite a bit. And it's got a little buzzer so it can beep. Although I might go with a larger buzzer because I actually have the room for it. I can maybe I can stick the buzzer down here. Like I actually have a lot of room. It's got a STEMMA QT port, so I can plug in sensors or buzzers or whatever I want into there. It's got a reset button, and then this is the OLED connector. So this is it assembled. So you can see here's the rotary encoder, and I actually have it running some CircuitPython code. That's why you get the little blink in the corner. This is the OLED. Of course, it looks flickery because of the camera, but in real life, it doesn't look flickery at all. It looks very nice, high contrast. And I put it on this side, so for people, most people have this on the right side of their computer. You'll be able to, you can reach over and press or rotate the rotary encoder. You can see the OLED. It won't be in your way. Your hand won't block it. And then I've got these buttons, and each button has a LED. And so right now I just have it. When you press the button, it toggles the LED, and when you rotate the rotary encoder, it changes the hue of the button. So this is just a demo, and then I can remove the key to show it's just a kind of standard Cherry MX key, and then I'll remove this one. Just you can see the NeoPixel underneath that lights through. So that's keybing. So the idea is just to make a generic MacroPad. It's not the the MacroPad that'll end all MacroPads, but it's like what's kind of like the most basic thing that covers most people's use cases. So I thought having a display and TFTs. I would have normally actually gone with a color TFT, but I actually can't get color TFTs right now because the market is completely screwed up. And so OLEDs actually I can still get. So I can put an OLED on, and OLEDs I think they're kind of nice. So you can do some configuration stuff, and then we can of course program this. Each key is actually not matrix. There's so many pins on the RP2040 that I actually have a GPIO for each pin, which is lovely. It's very easy to debounce them, and it's very easy to, if you want to have it, if you're using Arduino and you want them to connect to an IRQ, like you can do that as well. And then this is USB-C. I have a couple breakouts here just in case I want to connect other stuff, but so far so good. I haven't needed to do that. And then the thing I want to show that was kind of neat. Well, first off, with the RP2040, what is kind of nice is if you ever want to reprogram it, the bootloader is in ROM, but you have to press down the boot pin while plugging it in. I actually made the boot pin be the encoder, which there's a little diode, so you can see it can detect when the encoder is pressed. I actually made it so it goes a little brighter when that happens. That's how I'm testing it. But if you press this down while plugging it in, it will show up as the bootloader drive. So it's very, it's not, you won't do it accidentally, but even if it's an enclosure, you can still get to that button. And then the next thing, which I thought was kind of neat, was we recently did a PR. So let's go to my computer and I can show the PR. So this is PR number 4689. And this is from Dan Halbert, who has been working on dynamic USB descriptors, something that we've been actually, it's one of our oldest GitHub issues, so I'm really excited to close it. When we have CircuitPython boards, they automatically show up as a disk drive with all your files on it, a USB CDC REPL, so you can send it commands, and then MIDI device and also HID device, like keyboard and mouse. But there's a lot of situations where people are like, well, I don't want the disk drive to show up, or I don't want the REPL to show up. And in these cases, we kind of were like, well, you can build your own custom version of CircuitPython. It's really easy to disable it, but there's no automatic dynamic way to do it. It's built into the firmware. Well, as of 7.00, main branch latest, absolute latest, you can disable each individual part of the USB descriptor, so you can turn on and off each element as desired. So in this case, he's got some example code, and then I was going to write this code, and it turned out Defshipu actually wrote an example for me, basically. Although his is for a matrix keypad, but check it out. It's actually linked off. He commented at the bottom here. He's like, yeah, check out my example code. So I wrote my own version. So let's zoom in. So this goes into boot.py. And you have to import unit-only imports. And then I use the first key, and I set it up. Because it's boot.py, nothing is configured. You have to start from the beginning. You have to set the key as an input, add the pull-up. And then if the key is not pressed, I disable the USB drive. That means by default, the USB drive is deactivated. And then if I press the button, it means it'll keep the activation, right? So basically, by default, this MacroPad doesn't have a USB disk drive show up. But if you want to update the code, just hold down the first button. So let's show that. I'll show it on this side. And then, so let's go to my PC.
Yeah.
So you see there's no CircuitPy drive here, right? Nothing. But if I hold down this button, this is key 1. This is, you pick any button you want. You can choose a combo if you want, but I picked this one. And then I'm going to, just be super safe, unplug USB and plug in USB. Now it should, on the computer, it shows up as a disk drive. So this wasn't there before because I didn't have that key pressed when I plugged it in.
This is a big feature for people who make keyboards because you can always just boot into edit my keyboard mode. And
if you want, you won't accidentally get in there and people will be like, why does my keyboard have a disk drive?
Yeah.
And you can do the same thing for the USB CDC REPL. However, I will just say it's a little risky if you do this, right? Once you start disabling multiple things, if you're not absolutely positive you can get back into it, you're not like permanently locked out. Like this is not a security feature, but it can be a little annoying to get back in to be able to edit those files. So just be super careful.
One other thing, and there's some advanced folks in the chat. There's also some beginner folks. There's also folks who've never tuned into something like this. Look how easy it is to figure out what's going on in this file called boot.py. Import board, import digital I/O. Maybe you don't know what those things are, but then import storage, import USB CDC, import USB HID. So right away it's like, oh, this thing, this thing has storage and it uses USB, and HID stands for human interface device. So that's kind of neat. In looking at the code, the text itself, you're like, oh, this is the key that you press to make it get into this mode. So anyone can pretty much start to modify this and build off of it. And one of the things that we want to do, and this is, I'll go to this, we think this is going to be one of the first times people get into keyboards who do maybe lots of coding. They've never built their own custom keyboard, so we'll do a MacroPad first. And then there's going to be people who have done a lot of keyboard stuff, but they never really picked up coding yet. And they'll be able to do that with Python and with this. So we're pretty excited about it. That's why we want to show it off. Hot off the press.
Yeah, so it'll be fun. You'll be able to print out your mapping or customization on the OLED. So I have a couple more little things to do. I forgot to add mounting holes in the bottom, and I'll get rid of these breakouts, or I'll maybe put them elsewhere. And I want to change the OLED to one that plugs in instead of solders in to make it a little easier to manufacture.
Will the CircuitPython safe mode thing default to all descriptors on?
I think safe mode does, yes. So you can always get into safe mode, but I think safe mode is not quite working perfectly yet on all these boards, so just don't depend on that.
We will. That's one of the goals.
It's one of the goals, though, but it's just...
Yeah.
We have a couple solutions for this. Okay. All right, so that's the Keeb boar. Oh, and then this is, the code. If people want to I can just quickly show. This is the entire code for the whole thing. I set up the display, and I have the NeoPixel stuff, and then I'm actually using the Bouncer, which is this library that was written by David Stells, and it's actually really nice. It makes it really easy to do, was the key just pressed or just released, and it can handle. I think there's even an example for key matrices, but it's very nice because it handles the key rise, lower stuff, and I don't have to do that logic.
Is CircuitPython fast enough for the low latency keyboard input?
It's fast enough that you won't notice it as a human.
Okay.
Which is pretty fast. Not worried about it. This is running at 133 megahertz. It's faster than... it's delayed because I have actually a long delay between stuff, but it's quite fast.
And then for in the other chat, someone says, can I do this with MicroPython? No, not yet.
MicroPython does not have HID support for the RP2040 yet. I think they're working on it, but right now, if you want it to show up as an actual keyboard where right now it's not acting like a keyboard, I'm just testing it, but if you want it to actually type things into a computer, you have to use CircuitPython for that. I don't even think Arduino has support for that yet.
Yeah, I think CircuitPython is the only way to really do this right now.
Or Pico SDK, which is not fun. But you can do it.
That when we like using everything, but let's say if I had a really simple project and I have a Circuit Playground Express thing, I might use Make Code. Or if there's something that I care about, someone being able to edit it later and shows up like a drive, I'll use CircuitPython. Or in this case, if I want to do something and have it show up as a keyboard, I'd use CircuitPython. So luckily, all these boards, you can run whatever you want on it.
Yeah. Right, this is also not, it's a MacroPad. It's not a keyboard. You could do this with a keyboard. It would be plenty fast, but it's not a keyboard.
All right, what else?
All right, next up, we have added our pretty pins diagrams. We were showing off the tool that automatically makes these pretty pin diagrams. Yeah. So we did NRF52 boards. Phil B rocked out and did them. These are... Some of these NRF boards were really annoying. The clue, it's it doesn't have GPIO breakout pins, so it's a little tougher. But we did do that. We did the NRF52840 Feather and the Feather Sense, and these are just we have them as PDFs, so the font look good. This one was not too bad to make, but we like to pull apart the internal pins. But what's nice is, I created the CSV file for all of the pin muxing, and so all of that stuff happens automatically. And then I've started, folks can, you can run this on your own if you want to pretty pin your own boards. I've started we have the Arduino pin updates, and there's a pull request including I think the SAMD 21 pins. So maybe I can view this file. Oh, this is not going to be pretty. Okay, so for the SAMD 21, the thing that's kind of, it's a little annoying is like there's so many alternative uses for each pin, and we have to have them all in this table. So for every GPIO, there's the interrupt number, whether it has ADC, what's the touch, what's circom, what's the alternative circom, what's the timer, what's the alternative timer, and special inputs like I2S or debug or USB. So I did port A so far. Unlike other data sheets, I couldn't just copy and paste the data sheet. Like the MUX table for the data sheet did not copy and paste in, so I actually had to hand make this. But the good news is that you only have to do it once, and then of course it automatically generated. And then I have this hilariously bad code that you can check out where to determine the Arduino pin numbers for each underlying GPIO number. Like, so PA02 is Arduino 4 on the feather, or Arduino pin 8 on the clue, whatever. I actually open up the variant file and add a bunch of pound defines, delete all the Arduino includes, and I actually compile the variant file, which has the special structure. I kind of trick it into letting me compile it, and then it spits out the data in the structure, because it's very, very, very hard to parse C. It's easier to fake out the file and then add a main function that actually prints out all the pin definitions, than actually trying to parse the pound defines and the pin table itself. It's gonna be really, really hard to do that. So we did that, and so far so good. Yeah. So I just I in Python I create a C file, and then I let it run, and it runs fine. So we'll see. So far so good. I mean, is it hacky? Yes, but I only have to run it once per board. So that's that. Okay, so that's the Pretty Pins update, and I think that's all I've got for hardware.
Okay, a couple good questions.
Yeah.
I don't know the answer to this. I don't think you do either.
Yeah.
Do you happen to know the status of the RP2040 and the Chibi OS thing? I think that's the embedded.
I have no idea how Chibi OS is doing. I don't know of any RTOSs or how.
Yeah, I think that. Check out their forums. I think there's a thread on what they might try to do the reporting.
Yeah.
Okay. Will the OLED ribbon cable be long enough to route the display up to be flush with the top of the keys? I'm already thinking about designing a 3D.
Yeah, it's
printable
not.
case lull.
It's not, and there's no real way around it. It's just way too short. I mean, it's so short.
Yeah.
And if I tried to lift it, it would just tear off. So it's it's not the bestest thing, but for the price,
Here's what I'm gonna say.
it's going to be pretty good.
Yeah, you're probably gonna build lots of different versions of these. We're gonna have an e-ink one, one when there's different types of displays.
You can also always connect another OLED
Yeah.
with the STEMMA QT port. There's nothing stopping you from connecting a separate OLED display
Yeah.
on the alternative I2C address, and then using that as the display. It's not going to be that.
Okay.
That's fine. Go for it.
Is it a great search time?
Yeah, it's time for the great search.
Where in the world is that part I need? The great search with DigiKey.
All right. So every single week, everyone's talking about the chip shortage. Everyone's saying, "Oh my gosh, I gotta find out where I can get stuff from DigiKey, substitutions, part replacements, you name it." And there's only one weekly show that has a weekly segment, The Great Search, brought to you by DigiKey and Adafruit, where Ladyada uses all our powers of good to find the things you're looking for at digikey.com. So
Only powers are good.
what are you doing this week?
Okay, so let's go to the overhead, and I'm going to show this board off. So this is a board that it's okay for now. This is my little I2C to rotary encoder converter. And in the middle here, I've got my SAMD09. The SAMD09 is a very low-cost ARM Cortex M0 chip that I've got great pricing for, and I use that to read the rotary encoder, and then I act as a I2C peripheral, so you can query the peripheral about the rotary encoder. That's not having to do the rotary encoder math and pin toggling measurements and pin changes and neopixel controlling. That stuff's all handled by this little coprocessor that's controlled over I2C. Wonderful. And I designed like a whole bunch of different boards that were like it. Like I designed this board that has like 4 rotary encoders. This one here, which is it's brand new. And I designed one that has a slide potentiometer. Some folks have seen, over the last few shows, I've designed them. And I designed them all with a SAMD09. And that's when, the SAMD09 got kind of hit by this part shortage. And so since these boards were just designed, I don't feel too bad about swapping chips before I order PCBs, because if I can't get a chip, there's no point in ordering the PCBs on a lark. I should get something that I can actually acquire in the next, year or so. So I wanted to, there's also a couple things I wanted to improve on this design. Like this rotary encoder, by the way, is like a 3-year-old design, which we finally got out the door, which I'm very happy about. But there's some things I could improve. For example, the SAMD09, it's a wonderful chip, but it's 3 volt only, which means that for it to work over STEMMA QT, the I2C, I want it to be 3 or 5 volt compatible. So I have to have a level shifter MOSFET over here and a regulator over here for level shifting and regulating the possibly 5 volt power and logic down to 3.3 volts. So one of the things I would like to find is an alternative. If I'm going to get an alternative, I really want to save 15 cents a board and skip those parts, because I need fewer capacitors that way, fewer diodes, fewer placements. The boards can be smaller. You can see it's kind of packed in here. But I still wanted to be able to do all the things that I was having the SAMD09 do. And finding a chip that can do that, I thought I found a good chip, and then I'll show you. It turns out that it was not actually a very good option, because I can't get it in any future universe that I can see. But I want to find basically a microcontroller that is physically about the same size as this. It's not going to be pin compatible. I'm not expecting that. 3 to 5 volt compatible. Has 8 to 16K flash. This has 16K of flash memory, but I don't actually need all 16. I think I could do with half as much. I do need a bunch of RAM. I need at least 256 bytes of RAM, which doesn't sound like a lot. The I2C buffer itself, I'd like to be, it's going to be 32 bytes in and 32 bytes out, and then I want to control neopixels, and that can be another 64 bytes or so. So it's going to add up quickly. I need 256 bytes at least. I wanted to have an internal crystal. One of the things I really like about this is you notice there's no crystal or resonator. Those are 20 cents. So I wanted to cut that out too. What I really like about this is that other than the regulator, there's only 1 or 2 resistors and capacitors needed to get the SAMD09 up and running. So let's find something that is similarly very easy to get up and running. Needs very minimal additional hardware, because I don't care if the timing is a little bit slow. Because it's going to be 100 kilohertz I2C peripheral. Doesn't need to be perfect timing. Yep.
General question. Why is the processor rotated 45 degrees on the board?
Because it's otherwise it would have gone in the way of the pads. If you look at it, if this was not rotated 45 degrees, it wouldn't have fit. I wanted it to fit.
There you go.
And yeah, it wouldn't fit. Okay, so let's go to DigiKey and let's search for this microcontroller. And I'm going to be really flexible about the microcontroller, because so I'm just going to search for microcontroller, which I usually don't. Right? That's usually
Billions.
It's 100,000 results. So there's a couple different options here, but I really just want embedded. I want an embedded microcontroller. So let's pick that. So yeah, 90,000 options. So let's zoom in a little bit. So we're going to pick only active parts, because I want something that I can get in the next, again, year or so. I don't want something, if it's discontinued now, it's never coming back. I'm not going to pick stuff that's in stock, but I'm going to pick something that's normally stocking, right? Because obviously there's a lot of stuff that's not in stock, but might be in the next few months. That's okay. If I can get samples, I can always scrounge up some samples. I can get the designs developed, and then by the time the PCBs show up in a month or two, I'll be able to go into manufacture. So this already cuts it down by 3/4. So next up, we're going to actually start picking up specifications. So for GPIO, let's pick that first because it's a very easy thing. I want at least 12 GPIO. I actually probably want more, but the reason I want at least 12 is, look, I need 2 just for the programming pins. There's a couple programming pins. There's a reset pin. And then I want it to be able to control, a couple of, 4 buttons and maybe, 4 neopixels. And then I want it to have address selection pins and the I2C pins and then maybe an IRQ pin. Basically, you do the math and it's like, I need, maybe an activity LED. I need basically 12 GPIO minimum because I don't want to have a different chip for each of these boards, like one for the rotary encoder and one for the one with 4 keys. I want to have one chip for all of them. So I'm going to pick 12 minimum. So I'm going to use the min-max boxes down here. Great. Next up, I definitely only want to have a surface mount part. I am not going to through hole this, so surface mount. For oscillator type, I'm going to want, I don't know what dash means, but I definitely want not external only. Like external or internal is fine as long as internal is available. For program memory type, there's a lot of these types, but basically I just want flash. I don't want EEPROM or UV or OTP or MASCROM or FRAM. Those are all going to be very expensive. Flash is the least expensive, most common. So it doesn't actually cut away a lot of things, but just gets rid of the ones I'm definitely not going to use. Okay, so next we can start doing program memory size. So remember I said I need at least 8K. Now, of course, it depends on the compiler and the optimization and the core and how many bits per instruction. But 8 to 16K is kind of what I want, right? Because also, if you think about it, the original Arduinos were 8K, and then they use the Atmega 8, and they moved to the Atmega 16, and the 32 is wonderful. I mean, I can keep going, but it's going to get more expensive because what you're paying for when you buy microcontrollers is I/O pins. It's not really peripherals because the peripherals are the peripherals. You're paying for flash, RAM, and pins. The more you want, the more it's going to cost. But let's just go to 32K. So now we've really cut it down because we've gotten rid of a bunch. Okay, so finally, RAM. Well, all these are, these all have a fair amount of RAM. EEPROM, if it has EEPROM, great. So the next thing is I'm going to do that power supply, because remember I was kind of picky about the power supply. I really want it to run from 3 to 5 volts. In this case, there isn't like a min-max, so I'm just going to pick out the ones that go up to 5. So here's 5, and this goes up to 5, 5.5, 5.2. The 5.5. So you're just gonna kind of go through and pick up the ones that you want.
Oh, as you're doing this,
Yeah.
you have not been checking the exclude marketplace in all these. Is that to add possibilities during the shortages?
Yeah, I'm not going to be picky about that yet. I get picky about marketplace later, and also usually when, again, as I need something in stock right now and I need it like tomorrow. If this is something that I'm planning for long term, I'm going to pick normally stocking, because that means it might be out of stock today, but it would be in stock tomorrow. Marketplace, I'm seeing much more stuff showing up in the marketplace. It's not a bad idea, and the pricing can be better in the marketplace.
So the oscillator type, what's the difference between external, internal, and internal/external?
It means that you can have either. It can support, some chips don't support any external oscillator. Like you can't put a crystal on them even if you wanted to. So I don't care if it allows me to, I just won't connect pins. I won't connect a crystal to it. Okay, so I've picked up all the ones that cover 3 to 5. There's more here, but of course these go above 3.5 or 3.3, so I don't want them. Okay, so now we're down to about 3,000. Okay, so next up, I'm actually not going to select a core processor yet, and I'll show you why, because it turns out it doesn't really matter. I also don't care about the speed so much, because all of these are they're basically 8 megahertz or above, which is plenty fast for what I'm doing. All of these, I do like that these all have data converters. I'm going to pick only the ones that have ADCs. Some of these have like ADCs and DACs, and that's wonderful. They're all kind of a little different. Okay, so selected all of them except for the one that has a dash because I don't want any that don't have ADCs. Almost all microcontrollers these days have ADCs. And then finally, I'm going to do supplier package. So if you remember that board, I'm actually very picky about the package. I really, really want something that's in QFN, like 16 to 32 QFN, because those are very small. The yield is very good. They're easy to work with, and they're going to come in tape and reel, and I just like them. I don't want SOIC or SOP. They're going to be huge. I want something very compact. And I found that QFNs, these are sort of my favorite packages. So I'm going to pick out from the supplier device. I'm going to skip the SOICs, TSOPs, and BGAs. Depending on your soldering, sometimes people are like, no, I only want SOICs. I want them very easy to solder. Great, go for it. I want something very compact. So I'm going to pick out the QFNs, QFN, and then you said there's UQFN and VQFN. That's like the density, but I don't really care about those. So there's quite a few of them. That's okay. Let's get through them all. QFN, QFN. Oh, not QFP, not QFP. And then a couple more QFNs here. Although now I'm getting into once I'm getting into this many pins, I don't need something with this many pins. 32 is actually kind of the max. Although 33 usually just means the ground plane. So I'll add that in. Okay, so now we've really cut it down. So now we're down to 400 options. So we're not going to get all the way down to 2, right? That's not going to happen. However, we can start now. Let's look at prices at 1,000 pieces, because that's what I care about. So there's a couple options here, and I'm not surprised by the options. So the first one is the MS51, which nothing beats how inexpensive it is. However, when I went to put it in my cart, because it's like well, it doesn't have the lead time here, but I do the little trick where I put it in my cart, and then I click check the lead time here for 1,000 pieces, and it says it's not going to show up here till 2023, which I'm not even sure I'm going to be alive then. I have no idea what my life is going to look like in 2 years. So that's kind of scary to me. So that's why I did get a dev board for this before I saw the lead time, but it's a little bit too scary. For the rest of these, a lot of these were really good. I will say I selected, normally stocking. So all these looked pretty good. There was a lot of these had EEPROM, which I kind of liked. And once I sort of saw that there were ones with EEPROM, I sort of started thinking well, I kind of want to optimize for those. I want to have EEPROM because it is kind of nice if I can save the I2C address or configuration in it. So I started, once I saw that there were ones with EEPROM, I said, okay, well, let's filter out the EEPROMs ones. So the next one, so that actually got rid of the MS ones. So there's the ST8S. This one also had a pretty scary lead time. But what I liked is that there were a bunch of ATtiny 806 and then 816s. So these were the ones that were available and were about 60 cents in quantity before I even got a quote. And given that I had a choice between basically for the same, it wasn't that much different in price, the STM8 series and the ATtiny series. I actually ended up saying, okay, well, I'm probably going to try the ATtiny series just because I know that there is, an Arduino core for them that I can use, so I don't have to write as much code for them. The ATtiny 816 in particular, I liked. It had both capacitive touch and a DAC. So I ended up getting that one to start because I do use capacitive touch for the soil sensor, and I'm probably going to have to replace that one. I'm probably not going to be able to get that chip either eventually. So I ended up getting this as a sample. And what was kind of nice is for the, in my cart, hold on a second, go to my cart. When I checked the lead time, it was well, it's going to be, August, which was kind of which is actually pretty good, like because a lot of chips are not available till next year. So the fact that they're going to have it in a couple months was kind of promising to me. I liked that idea, and they did have SOIC versions of this chip in stock, which I ordered. So I got a dev kit for this board, so I can show it on the overhead real fast for this family. And this is the 817, which is a little bit bigger, but it has the debugger built in, and has capacitive touch, which I thought again it's just kind of a neat thing. Buttons and all the GPIOs, and this even has like an Arduino-y pinout, so I can get started with this. And there's the X Mega Core, which uses this chip to give it like an Arduino compatible core, so I can use things like the wire peripheral code. I don't have to do a lot of porting from the existing Seesaw code I have. I can port it into Arduino, which I'm very comfortable with. I should be able to do that in about a month. And then I can kind of redesign all the boards that I just did into this new chipset. And I like it. It's a very, very compact chip, very inexpensive. It's about 50 cents per. Has everything. And then to program it, it actually uses a one-wire program, which is asynchronous UART. So I don't even need to have all 6, SPI, ISP pins like most, if you remember most at Megas or at Titanies, you have all 6. You need 6 pins. Clock, mostly MISO, and reset. You don't need those. You only need the reset pin to program it. So this is my great search. I think this chip is the right chip, so I'm going to get some. And if you're looking for a low-cost microcontroller, I think this one's going to be in stock, so check it out.
And if you're not looking now, don't worry, you will be soon. Okay, that's the great search tonight.
All right.
Where in the world is that part I need? The great search with DigiKey.
All right, and that is Desk of Ladyada for this week. Don't
Yay.
forget, Wednesday we'll be doing show and tell. We're hosting it. And then Wednesday night, though, 8 p.m. is Ask an Engineer, but it is the AdaBox unboxing, so you'll see that with JP.
That's right.
All right.
So if you got your AdaBox, tune in and get the guideline. Got lots of projects. It's a good one. Come on by. You might see JP dress up.
One question before we go, since one came in. Hello, you recently did a bunch of rotary encoders. Do you have, or are they absolute or just integral?
The rotary encoders are not absolute. They only increment positive or negative. You're thinking of a rotary switch, which has absolute, but they're much tougher to rotate, and you need a lot more pins for them. These are just 2 pins.
Okay. All right. Question right at the wire.
All right. Thanks, everybody. See you next week.